All right, so good morning, everyone, and welcome back. Like Paul said, my name is Kaylin Kautzman, and sticking with tradition, I love to start things off with a joke. So, how do you tell the difference between an introverted and an extroverted engineer? The extrovert looks at your shoes while he's talking to you. That was better received than my last one, so thank you. So our next speakers will be Greg Thelen and Jon Bach, and they will be discussing the design and construction of US 85 from the Theodore Roosevelt National Park to McKenzie County Road 30. And both gentlemen are registered engineers with KLJ Engineering, and let's welcome them to the stage.
All right. Welcome, everybody, to today's presentation on the most recently completed project along US 85. Now, there's been a lot of history on this corridor, and there's a lot to talk through in the next 50 minutes, so let's go. We'll start by going through the corridor history. There's a lot that's happened over the last 2 decades. We'll give you an update. Then we'll go into some design features of the most recent project south of Watford City. And then we'll touch base on right-of-way and utility coordination. And then last but not least, we'll give a detailed overview of the construction process itself. So I'm Jon Bach. I work for KLJ. I was the lead designer and assistant project manager for the project in the design phase. And with me today is Greg Thelen, also with KLJ. He was the construction project manager. So that corridor history, it's important to understand how we got to this point today. So the project purpose and need goes back many years. The orange areas go back about 15 years. That represents the 4 lanes that the state had at that time. There's a gap. There was a gap between Williston and the city of Belfield. That was 2 lanes, that's US 85. The oil boom really made it a prevalent need to get it to 4 lanes of traffic. That had over 10,000 vehicles a day, well over during that time, and the demand is still high today. So some historic construction, what's been done up till this point? Starting back in 2013 to 2017, there were 6 projects executed by the DOT between Williston and Watford City to get it expanded from 2 lanes to 4. I myself had the pleasure of working on 3 of those 6 projects. Watford City Bypass was another that was executed between 2013 and 2014. And then there was a 5-year effort for preliminary design and environmental to produce the environmental impact statement between Watford City and Belfield. And that was like 64 miles of effort, huge coordination effort. Now, the first project that was executed in final design and construction from that EIS was the replacement of the Long X Bridge. That was an 85-foot shift with a brand new bridge, realigned the highway over the Little Missouri River. The second project was the Horseshoe Bend landslide repair. That was just north of the Long X Bridge, and that was to mitigate a fault plane landslide that extended underneath the highway. And then now, this is the project that we'll talk in detail today. This is the 11 miles south of Watford City that was most recently completed in 2024. Now, there's also some future anticipated construction that'll occur. There's 3 separate projects between the North Dakota 200 interchange leading up to the Long X Bridge. Those are currently in a final design phase with construction projected as early as 2026, and those dates are subject to change. And then the remaining portion has projects currently in the preliminary design stage, and they have estimated construction start of potentially 2030, again, dates subject to change. And I myself have had the pleasure of working on about 2/3 of this corridor with either prelim design or final design. So now we'll get into the design aspects and elements of the most recent project, which is 11 miles south of Watford City. And we'll start with the project team. KLJ was selected as the prime consultant. We perform project management, environmental services, roadway design, structures design, right-of-way, and survey. Also on our team was Apex Engineering Group. They did roadway design, hydraulics, utility coordination, and survey. Shannon and Wilson was very influential for the geotechnical side of things. Braun intersected soil borings, and Martinez Geospatial helped us with some of the LiDAR survey. So project location map, where is this? North is to the right, Watford City is on your right, and the project began just north of the Little Missouri River Bridge, at the Long X Bridge, at the entrance to the Theodore Roosevelt National Park. Then it extended 11 miles north to McKenzie County Road 30. That is in essence where the Watford City bypass began, basically filling in the gap between those 2 projects. Now, a lot of typical sections, a lot of variations were prevalent on this job, so we broke it up into project segments for final plans, and that's how we'll talk about it today as well. So I'm going to focus on each one of these sections, starting with segment A. Now, this is from RP 127 to 130, but it's not 3 miles in length. There is a unique RP equation on the right side of the screen, so it's just less than 2 miles in length. And if anybody has a chance to drive this corridor, this is the one you want to focus on. As far as alignment, we did match the existing alignment, except for 4 curve corrections. And the posted speed was 60 miles per hour. Now, the EIS development looked at many alignments, many typical sections, many variations to consider, and out of that process, it was concluded that the design for 60 miles per hour would proceed to final design. So typical section, what did we actually do? What did we design? Number one, we needed to maintain using the existing infrastructure, the existing pavement as much as possible. Doing bypasses, widenings in this area just wasn't a good option. So we did do 2 8-foot shoulders, 2 through lanes in each direction, 4 total, and then a 12-foot median, flush median as we're calling it. That was to separate the directions of travel. Later on, you'll see the same typical with a slightly different median width. 12-foot was chosen for segment A just because of the constraints that were prevalent here. Now, I mentioned those curve corrections. The existing and the proposed alignment didn't always match within those curve corrections, modifying radii, there was some slight variations. And then when it comes to expanding a road from 2 lanes to 4, super elevation transitions are going to get longer. Going from 1 lane's rotation to 2, we need to implement some overlay wedges and or tapered mill to get the super elevation to match the final conditions. Next, we'll go into some detailed plan view. Segment A has a lot to go through. There are wildlife jump outs. There's bored culverts with drop manhole structures. They had there's erodible soils out here. The drop manholes were your standard manholes, but they were put at pretty much the end of every culvert to get that energy dissipation down so that when water was discharged, it reduced the likelihood of erosion. And we had a requirement to meet less than 7 feet per second within this corridor. Next, we got actually the last slide also had a curve correction. There was a realignment that was done back in 2011, which kicked into first curve correction. The curve length was too short. Needed to lengthen it to meet AASHTO. The remaining 3, the black callouts, 2 of them were for spiral length corrections for super elevation transitions, and another one was just to simply convert it from a spiral to a simple curve. But this section has by far the most design elements to talk through, starting with the landslide repair with horizontal drains, then the scenic overlook with the pedestrian wall, and then the cast-in-place retaining wall. We'll go through each of those 3 next. So starting with the landslide repair, a little more history on this one. We have the existing alignment in black, and then that's the approximate 1980s alignment, call it the original alignment. That's Horseshoe Bend. If anyone wonders where that term came from, that's the alignment where the name comes from. Then in 2011, the alignment at that point was the blue. There was a slide issue, so the road was realigned to the black. Then most recently, the Horseshoe Bend landslide repair was executed. That installed drilled shafts into the ground to help mitigate that landslide fault plane that extended underneath the road. That was to correct the downhill side. Then the project at hand that we're talking in detail today, we corrected the uphill slide portion. That was the green area. So the picture on the left, that's the existing conditions. You can see a lot of landslide debris has fallen down. And it's a large area. It's a big footprint, but as far as its length, it was only 600 feet. But it extended many feet outside of the roadway footprint. So from a cross-sectional cut, that detail in the bottom right corner, got some arrows on there to help you visualize what it looked like. The goal of the landslide repair was a couple things. Number one, get rid of all the existing landslide debris that has fallen. That was loose material, it was unstable. And then the second was to excavate enough material to get to stable bedrock, stable ground, so that it would stay in place when the project was over. Now you can imagine there was a lot of dirt, a lot of excavation that came out of this hill, and that's true. There was over 330,000 cubic yards estimated in that 600 feet, which was a significant amount. And then for further mitigation, there were horizontal drains installed into the slopes. Those were, think of them as perforated tubing that gave water a place to go and to get out of the hillside, further mitigating a risk of future landslides. So those horizontal drains, just to give you a scope on what it looked like, there were each one of those blue lines is 110 feet long, and you can see there were plenty of them put into the hillslide just to help mitigate that risk. And Shannon and Wilson, they were our geotech engineers on the project. They provided a lot of all the analysis and the recommendations for this landslide. And from a scale, if you weren't out there to see it, here's a good picture that I have that kind of gives you an illustration of how big it was. You can see the white pickup on the top of the hill and the excavators. I mean, we all know how big those are. This is a good visual on how big that excavation truly was. And there's a picture of what it looked like in the end with some of the erosion control blanket installed from the ground. The next one we'll highlight is the scenic overlook. There was an existing overlook here, and it was redesigned and reconstructed with this project. And there was a lot of elements that had to fit in a small footprint with right-of-way, so we did not encroach into adjacent properties. So first, there was curb and gutter installed to help delineate where it started and stopped. Second, a decorative pedestrian wall was put to help further delineate where peds should and should not travel. At least that was the hope. And then there was a retaining wall put down at the bottom of the hill so that the embankment slopes did not extend into the adjacent property. And that had a chain link fence installed to help kind of protect people from a drop-off. The vertical exposed edge of that wall was roughly 8 to 9 feet, and it's the highest extent. And then lastly, there was a wildlife fence installed adjacent to that. So here's some pictures of the finished product, and it will highlight those elements. The retaining wall with the chain link fence, the decorative wall, of course, curb and gutter, and then the wildlife fence. And now the pictures on the right side just show the same things from a different vantage point, but we're happy with how it looks and how it functions in the end. The next is a retaining wall. Now these pictures won't do it justice. Greg's going to have some great pictures in the construction portion of the presentation that'll illustrate this better. But in its geometry, it's 265 feet in length. And why was this one put in place? It's similar to the scenic overlook. It was put in place to prevent impacts to the National Park Service. And 265 feet in length, like I mentioned. And the bottom right corner is the profile view. You can see it was not uniform. It had different benches, different segments. It had a profile on it. At its largest height, it was 16 feet in height. With that wall came a very significantly sized concrete foundation. All the piling was battered, and it was a significant effort in construction to get this complete. Now here's a finished product. There's a lot more concrete that's buried underground, but just to give you a visual, that's the retaining wall itself. US 85 is on the right, and you can imagine this is very difficult to see from the highway as you're driving. Then I also forgot, on the previous slide, there was 2 culverts that extended through this retaining wall. That was a structural challenge for us to work through. But the manhole covers are on the back side of the wall. Wildlife fence is adjacent to it, and then the culverts that discharge the drainage. Now we're getting out of what I'll call the Badlands towards the end of segment A. We got 2 wildlife jump outs, and then this is also where the proposed trail begins on the project. Now it's going to be more prevalent in the other segments. But just from an aerial view perspective, here's the finished product with the final grading and paving. 2 wildlife jump outs are there, and then this is where the proposed trail begins. Now, wildlife accommodations were a huge aspect of segment A, and we'll go through each one of those separately. Starting with the wildlife fence, we had 2 heights, 7 foot and 10 foot. Those were heavily coordinated with the North Dakota Game and Fish, both during the prelim environmental impact statement process and final design. We met on site, we had Teams calls, we analyzed and talked with them about where should this go. There was a total of 24,000 feet installed within segment A. Next is wildlife jump outs. For anyone unfamiliar with these, think of an animal or getting stuck inside state right-of-way with fence on both sides. How do they get out? So these were strategically placed in coordination with Game and Fish so that an animal would run along the fence, climb up the grade, kind of see that perpendicular barrier fence as an obstacle, and then jump out. And then the vertical edge on the other side was a prominent enough feature so that they wouldn't jump over. So there were 8 of these installed within segment A. Next are wildlife guards. These are not your standard cattle guards that you'd use for grazing applications. These were heavily customized and coordinated with Game and Fish and NDOT ETS and intended for use for bighorn sheep. So again, highly customized, they're large, they were 32 feet wide, 16 feet in length, and each one of those came with a price tag of around $57,000, and there were 5 of them installed on the project. And then vehicle gates. Any approach that did not get a wildlife guard, that needed to have a gate that met or exceeded the adjacent wildlife fence height. There were 6 of them installed, and they were either double gates or single gates. Now, these things were quite heavy. We had to make some adjustments in the construction with some extra bracing to make sure that those wood posts didn't fall down. All right, next we're going to get into segment B. This is the longest segment on the project, and it's also our divided depressed highway segment of the corridor. And the existing alignment that was in existence before this project was done, that is now the southbound through lanes of the divided depressed highway. And then northbound was a brand new alignment that was built over the previous 2 years. This came with a posted speed of 70 miles per hour along the corridor due to the divided depressed nature. And again, that EIS process, it analyzed many typical sections, many alternatives, many conflicts. And when all of those things were considered, cultural, environmental, right-of-way, construction cost, it was determined that the expanding to the east was the decision to move forward into final design. From a typical section, like I mentioned, on the left, that would be the existing highway or proposed southbound today. That was simply a sliver grading, widening, and overlay project. And then the right side, that was the brand new construction of northbound and the trail. And the separation between center lines was 84 feet. Now I'll highlight the beginning of segment B and then the end of segment B. At the beginning, the first feature to highlight is the South Amahami Trailhead. Now the trailhead is meant for an area where people that want to use the trail for recreational use, they can come and park here. That had gravel surfacing, park their vehicle. I think there's one bike rack out there. Then there was a paved trail connection that had to meet ADA compliance that leads you to the trail, and then you can use it for recreational use. So from an aerial view, there's your trailhead is on the right, trail connection, and then you can clearly see with the asphalt break where the divided depressed highway begins. Just north of this, we have our highway patrol turnouts. These are either chain up areas or chain down areas, depending on which direction you're going. And these were heavily coordinated with the highway patrol. We had to consult them on the geometry, how it would function, and of course the terrain and making it a potential inspection site. So these are quite wide, 32 feet of open space plus a 4-foot shoulder, and then there's like a 16-foot bump out that's intended for parking for a patrol officer so that they could be safely out of the way. Now just from a scale perspective, thankfully this aerial photo has one semi-truck parked in it just so you can get an idea of how large they are. And this one can be used as a chain up or an inspection site if needed. We were able to fit the necessary grades, profile grades, cross slopes, so it could be used as an inspection site if needed. Now we're going to skip approximately 5 miles north to the end of segment B. What did we miss in the middle? We missed a lot of culvert improvements, cattle pass extensions, a lot of approaches, access management, things of that nature. But as we extend out of the divided depressed median, just a visual on what it looked like, extending back into what is a flush median section in segment C. Now segment C is a little shorter. It's only a mile in length. It goes from roughly RP 135 to 136. We did match the existing alignment in this area, and it does transition into segment D a little bit, and our posted speed was 65 miles per hour. The one unique thing here is we did do a full reconstruct, and that was due to the transitions from the divided depressed with the curve corrections and then also transitioning into what is segment D. This area was a full reconstruct. So on that typical, that's why you do see a full reconstruct here. It's very similar to segment A. The one difference is a 20-foot median instead of 12. 20-foot was the preferred width. Like I mentioned, segment A had a reduced width just due to the impacts that it incurred. Now that black line, that represents the existing alignment. You can kind of see the yellow and the proposed pavement marking kind of pushing away to the upper part of the screen. That's in preparation for what is segment D. Segment D actually had a shifted alignment. So you can see it here. Segment D would be on the top part of the screen. That orange line represents the existing, and you see how the road kind of pushes away. All right, segment D. Kind of gave it away on what's going on here. It's shifted alignment, but how much? It was 40 feet total, 40-foot shift to the west. Over a 2-mile stretch, had a posted speed of 65 miles per hour, thanks to the flush median. So from a typical, just to give you a visual, even though it shifted 40 feet to the west, the footprint of the expanded roadway still overlapped the existing center line with how much pavement we put out there. Now here's a visual on, probably asking yourself, why did the alignment, why was it shifted? Why not stay on the existing alignment? Well, ultimately, we had this water tributary known as Spring Creek that extended through the project. And you can imagine if we stayed on, this is final design. The green lines represent our grading limits. We didn't impact that at all. If the alignments were on top of each other, this would have been impacted. Through that EIS process, that was analyzed and determined wasn't going to go forward to final design. So avoidance of Spring Creek was the reason why the alignment was shifted. Also within segment D was the Spring Creek box culvert. That Spring Creek crossed underneath US 85. There was an existing bridge in this location, and we revised it, we replaced it with a double box culvert that had a 13-foot span and a 14-foot rise. Now the box was quite long, 147 feet, and that was to encompass the roadway expansion, the 4 lanes, plus the flush median, plus the trail. And again, 13-foot span, 14-foot rise. There's a picture, aerial view, what it looked like in the end, and you can see the trail on the right kind of shift closer to the highway, and that was in an effort to keep that box length minimal. Next, when you shift away from the road, you got to come back. So now we're at closer to the end of segment D. That black line is the existing alignment, and the yellow, that's the proposed road. So this is a good view. You can really see that curve transitioning back onto alignment at the end of segment D. And last but not least is segment E. This one's approximately a mile in length, gets us to the end of our project, and this one matched the existing alignment fully, and it had a existing posted speed of 55 miles per hour from the Watford City bypass, and that was maintained with this project. So a typical section, not as much was going on in this one. The predominant improvement was an overlay. There was a little widening in here, but mostly overlay. And we did grade the new trail on the right side as well. And then there's one feature to highlight in this segment, and that's the North Amahami Trailhead. Similar to the south location, it has a gravel surface parking area for people to come and park their vehicles and then get themselves connected to the trail for recreational use. And there's a picture of the trailhead on the right with the connection, and then you can see the variation in color of the asphalt pavement. You can see where the project ends at McKenzie County 30. All right, there were a few design features that I've talked about that were kind of prevalent throughout the segments, not just in one, and that's predominantly the proposed trail. That's a big feature of this project. It was an 8-foot wide asphalt paved trail. It was installed on the east side of US 85, and it extended from County Road 34 up to County Road 30, and it had a cost-sharing participation with both the DOT and McKenzie County. Now, I get a lot of questions on this trail, and the most predominant question is, how come it doesn't extend down to the national park? And the best answer I can provide is through that EIS process, that coordination process. The national park's infrastructure was not built to accommodate both vehicular traffic and pedestrian traffic. So they did not want to encourage pedestrian movement down to their park because their infrastructure didn't support both vehicular and pedestrian movements as people traveled into the park. So that's why it doesn't extend down. And then why is it on the east side? Kind of the same thing with the typical sections of the other segments. Impacts were analyzed, conflicts were looked at, different options, and utilities, right-of-way, environmental, cultural, all that was looked at, and it was deemed through that record of decision on the EIS, it would be placed on the east side of the highway. Another one is the safety corridor. This is a highly traveled road. The DOT designated this as a safety corridor, so we did implement some additional features from your standard project. A couple that I'll highlight, we did implement vehicle speed feedback signs. You probably noticed as we transitioned from segment to segment, the speed limit changed. It's quite prominent, so we wanted to install some radar-detected signs to help inform people of the change, and we also put custom pavement marking messaging within the through lanes to help call that out. Next, I'll touch base on right-of-way and utility coordination. Can't have a project without these. They're highly, highly important. Now, a few statistics on right-of-way. There were 21 total plats. If you count the A, Bs, and Cs, the supplements, there were 25. We had 157 parcels that came from 33 unique landowners that amassed to 170 acres of permanent right-of-way and or easement, and then 22 acres of temporary construction easement. Now, that's a significant effort. Thanks to the North Dakota DOT ETS division for helping us see this through. Next was utility coordination. Again, some more statistics just to give you an idea on what the effort that was put in. This was performed by Apex Engineering Group on our team, but there were 16 individual utility companies. And then from an encounter summary, there was about 43 miles worth when it went in total. 6.5 miles of protect in place, which were the level 1s and 2s, Your level 3s and 4s, those are your horizontal or vertical corrections. That was about 17 miles in its own. There was 6.5 miles of abandoned lines impacted, and then the proposed resolutions to correct the level 3s and 4s was about 13 miles. So you can imagine the coordination effort that was necessary on this to make this a reality. And that coordination, just to touch on it again, things like Microsoft Teams, those web meetings, those were essential in keeping people up to date and meeting with all the companies and entities in a timely manner. And that special provision that comes with the plans, the table and the exhibits, that was a living document for our team. Going from final plans to bidding to construction, and even after construction started, utility work was being performed and updates to those documents were made continuously. And then I'll leave you with a few more statistics. We had 20 fuel line crossings within this corridor. We had 2 major overhead transmission lines, one with WAPA, one with Basin Electric. There were over 8 miles of overhead electric lines impacted and over 7 miles of telecommunication lines impacted. So now we'll kind of take a pause from the detailed design topic and we'll get into some fun facts, things you guys can take away. So first one is, how many years did it take from start of prelim design to end of construction? The answer is 10 years. The EIS was executed in 2014 and the construction ended in 2024. Within that time frame, there was 3 years of final design and then 2 years of construction. Next is, how many cubic yards of embankment were estimated in order to build this project? Now, those are some big numbers on the screen, but the answer is 2.2 million cubic yards. 1.5 million came from Common X on the project itself. The remainder came from borrowed sources. Next one, this one always blows my mind. What is the total length of pipe in miles needed to maintain drainage? The answer is 3.7 miles. If you take all of the existing pipes that remained, plus the proposed extensions, plus the brand new pipes and put them end to end, it would lengthen to 3.7 miles. There was a lot of pipe out here to maintain the drainage. And then at the time of bid, the project was the highest cost for a single project in DOT history. Is that true or false? The answer is true. It was the highest costing single project, and the low bid was $77.3 million with Central Specialties. Now Greg's going to give you guys a good explanation of the construction process.
Thanks, John, for talking about the design and utility aspects of the project. We're going to move on to the construction phase. Just some kind of quick facts about the construction job. The bid opening was January 13th of 2023, and we had a DBE goal of 0%. As John mentioned, the low bidder and future prime contractor was Central Specialties with a bid of just over $77 million. This was originally a completion date contract with a completion date of October 5th, 2024, so a planned 2-year construction window. But after all the change orders, the completion date was October 14th of 2024. Things got started on March 13th, 2023 with some tree removals. For year 1, winter suspension was achieved on December 4th, and then the work resumed again on March 18th of 2024 with the continuation of the horizontal drains. And then CSI was able to achieve substantial completion on the completion date of October 14th, 2024. Going into the construction team here, North Dakota DOT selected KLJ as the prime consultant. In that role, KLJ provided inspection, contract administration, survey, environmental, and paleontology services. KLJ did have 2 sub-consultants as part of this project. Bros Engineering provided the material testing, and Shannon and Wilson kind of continued their design role, providing geotechnical support and inspection of the related geotechnical bid items. Now, this project had quite a few environmental commitments. I'm just going to highlight a few of them that either impacted construction or had the potential to have a major impact on construction. So when this job was bid, the northern long-eared bat had just recently been listed as endangered. And with that, there were restrictions on the tree removal dates. We could only remove trees between October 31st and April 1st of any individual year. And as John mentioned, an existing 3-span bridge was replaced with a box culvert through Spring Creek that had your typical North Dakota spawning restrictions for the creek when work could not take place within the channel. There were 4 cultural avoidance areas on this project. Now for construction, the impact was fairly minimal. We just had to set up safety fence before work took place and keep it maintained for the duration of the project. But during design, they had to avoid any disturbance in those areas. We were on the lookout for endangered species as part of this project. The three specifically were the whooping crane, the Dakota skipper, and the northern long-eared bat. And the project team maintained vigilance, but we did not end up spotting any of those on the project. And there was a eagle and raptor nest survey requirements that had to be conducted each season. And these surveys covered the entire project area in all the land within 1 mile of any direction of the project, so a pretty extensive effort to get completed. The KLJ biologists searched for these nests from the right-of-way in publicly accessible parcels and roadways. Each year, 16 nests were discovered. However, their locations were far enough away from construction that we didn't actually impact the progress. And there was one parcel of U.S. Forest Service land as part of this project. There was an environmental commitment to perform a sensitive plant species inventory on this parcel. And then the U.S. Forest Service has specified timelines for when that survey could be completed. We did end up completing that survey. No sensitive plant species were identified, so then we were able to move forward. And probably the largest environmental commitment that had the biggest impact on construction were the migratory bird requirements. Now there was one SP, but kind of two separate requirements. For the clearing and grubbing operation, a survey had to be conducted within 5 days of any disturbance, anytime between February 1st and July 15th of either season. And with the contractor's operation, with the pipe crews out ahead of the grading crews, during that timeline, once things got started, the KLJ biologists were pretty much out there every week checking new areas for birds' nests. As part of that 2-year effort, the biologist surveyed just under 300,000 linear feet of ground disturbance. And the second requirement was for the migratory birds at structures. Now, at the structures, there was no timeline that the survey had to be done. Just whenever you wanted to do any work, if birds were present, the survey had to be done. Now, this one did have a pretty large impact on construction, is when the contractor was wanting to remove the bridge. The biologist came out, and there were 25 nests found at that structure. This caused about a 3 or 4 week delay as the contractor was waiting for the nests to turn to an inactive status so they could be removed. I've got some photos here of kind of what we were typically finding with the migratory bird surveys. The upper left-hand side, you can see a typical ground nest that was found during the clearing and grubbing operation. Bottom left is how we delineated that 25-foot buffer zone around the nests. And with the large scale of the project and so many people out there, communication was key. When we did discover one of these nests, the contractor was verbally told on site, the project manager was sent an email, and then the lath with the ribbon out there around the buffer zone made it very clear to anybody, even if they didn't know that the nest was there, that there was something in that area and they shouldn't enter it. Now, I mentioned those nests at the structure. You can see that in the top row middle picture. Those nests were kind of tucked up right up underneath the bridge deck, making it very difficult to determine if those nests were active. Now, nest is considered active if it's got chicks or eggs in it. And this particular species of birds we had multiple broods a year. So there could be a small window when you could get in there and remove the nest after the one batch had fledged and before new eggs were laid. With that, once we were in that 3 or 4 week period where we were trying to remove the bridge, the biologists were out there 2 or 3 times a week checking, so then we could communicate which nests had been deemed inactive, and then the contractor could remove just those nests while waiting on the other ones. And in order to determine the activity status of the nest, because you can't really see in them with them under the bridge deck there, the biologist used a telescoping camera to peer inside the nest and capture some photos. And on the right-hand side of the screen there, you can see the kind of photos they were capturing of the interior of the nests. And kind of hand in hand with the environmental commitments were the paleo commitments. There were 2 sort of commitments for this job. Through the Badlands area, full-time monitoring was required. So anytime the contractor was out there moving dirt, the paleontologist had to be on site. The rest of the project had to have what was deemed a windshield survey done. And this was once during excavation and once after excavation. The paleontologist had to drive through and check for the presence of bedrock. Bedrock meaning just any native undisturbed materials. And if they did find bedrock, then they had to fully conduct a pedestrian foot survey. And as part of this project, we found 73 fossil localities almost entirely located within the Sentinel Butte Formation, and 60 of these localities were located just within that landslide repair area. Mostly what was discovered were invertebrates and plants. Some photos of what we found. One common resource identified were these leaf imprints. They kind of came in two types. On the left-hand side of the screen, you can see just a leaf imprintation into the sediment or rock. In the right-hand side is what was referred to as a lignitized leaf impression, where the leaf itself had been turned to lignite. Another prevalent resource identified were these clamshell fossils. These were mostly found in the blue and gray mudstone. One unique thing about these is we wouldn't just find one at a time. It was typically when you found them, they were in a bed of like 20 to 50 fossils all located in an individual area. Probably the most unique fossil resource identified as part of the project was this Chomposaurus limb bone. And what I got on the right-hand side photo here is as it looked as the paleontologist discovered it. And at least to me, that doesn't look like anything significant that needed to be identified. I'm imagining most people in the room probably have that same understanding of it. This just kind of highlights the importance of having the people with the proper training and proper skills out there to identify these resources, because on the left-hand side, you can see the picture of this limb bone after it had been brought back to the lab, cleaned up, and reassembled. We did run into a few mammal partialized fossils, those being bison and fox, same as the previous page. You can see the as discovered on the left-hand side and after cleaned up on the right-hand side. And these ones were only partially fossilized and representative of the modern species, so they likely came from the Quaternary period of time. And the last source of paleo resource we were finding was either lignitized or petrified wood. These were pretty prevalent, especially for small chunks. We did discover one fairly large chunk here. It was a 35-foot long lignitized log discovered in the landslide debris. This one did kind of have an impact on construction because the contractor had to avoid that area for about a day and a half after it was discovered, as the paleontologists were uncovering it, taking samples of it and documenting it. Those other fossils that we looked at earlier was typically only like a 5 or so minute delay for the contractor, if it could even be considered a delay, as the paleontologist sampled those resources. This one was a little longer just due to the scale of it. And due to this lignitized log not being very durable and being deemed likely to deteriorate if it was transported, it was just sampled, documented, and then stayed as part of the fill. And as John mentioned, at the time of bidding, this was the largest project North Dakota DOT had ever put out for construction. Got a couple facts here to kind of demonstrate the scale of this project for some of you. So there were 55 total subcontractors on site. 31 of those were trucking subs, but that still leaves 24 contractors out there performing work. KLJ Engineering performed over 1,700 unique density test locations, and that's just the test locations. If you were to try to determine the actual test number, you could probably double that. We paved for 49 days and cut over 1,000 cores for determining pavement density. Over 1.5 million yards of on-site excavation. Now this included both common excavation that was excavated from the site and remained on site, and coal waste that was excavated from the site and disposed of off-site. Over 500,000 yards of borrow were imported as part of the project. Just under 352 acres of permanent seeding. Gives you an idea of the scale of the amount of land impacted as part of this project. And if you were to include temporary seeding, you could probably double that number. We placed just under 500,000 tons of Class 5, over 4,300 linear feet of pile, over 9,000 linear feet of open trench pipe, over 1,700 linear feet of jack and bore pipe, 78,000 linear feet total of fence. That was including both barbed wire and temporary fence and the wildlife fence. We were right around 2,500 linear feet of wildlife fence. We removed around 134,000 tons of pavement and 2,400 linear feet of pipe. Now I'm going to move into talking about some of the kind of key highlight items as part of the construction. Before that, with the scale, you can imagine there was a need for quite a few changes. This project had a total of 15 change orders, resulting in a net decrease of just under $11,000 and an increase of 9 calendar days. And these change orders kind of broke out as 5 of them were for force account, 2 were for utilities, 2 were to add additional bid items, One was to accommodate a landowner's request for access changes. 2 revisions were made to the winter suspension requirements, and 3 of these change orders were initiated by the contractor proposing different techniques or materials that came along with the cost savings to the department. And as well as the change orders, we did utilize the PS1 schedule pretty extensively throughout this project. There were just a lot of unknowns and things that got discovered on a job of this size. A couple items to highlight: over 12,000 cubic yards of rock excavation and over 2,000 cubic yards of muck excavation. So the cast-in-place retaining wall John had talked about earlier, we got some photos of the construction here. This was broken down as CSI performed the excavation for the wall, the backfill, and the installation of the underdrain. Viton Company drove the pile, and Wind Construction placed the concrete and reinforcing steel. And even though we did use over 4,300 linear feet of pile, that was still a 25% underrun on pile quantity. As John mentioned, every pile was battered, and every pile did also have a pile point. Kind of a unique thing about this area is you didn't really kind of creep up on bearing and were able to see it coming. When you hit bearing, you hit it and the pile almost just completely stopped moving. As well as the cast-in-place retaining wall, we had 2 types of block retaining walls. The first type was the small block MSE wall that was only located at the scenic overlook. The second type of walls where we had big block walls, these were for the jump outs and the decorative wall. Premier Landscaping installed all the block retaining walls. In lower left-hand side here, the photo is of that MSE wall about halfway through construction. You can see part of the underdrain is still unrolled and not quite installed yet. How these walls work is they're small blocks of concrete with geogrid in between some of the layers, and then you backfill aggregate over the geogrid, and that weight is kind of what holds the wall up. That middle picture is after we poured the footing for that MSE wall. Pouring that footing was a little bit difficult. You can see there were quite a few steps, just changes in vertical elevations. And then one thing you can't quite see from the photo is the footings are also offset to get the top of the wall, because the wall is different heights to be at the same alignment. Now on the right-hand side, you can see a kind of a finished wildlife jump out. Those had that nice natural rock color and texture to them. However, you're not able to see that from the highway. That's the private landowners, national park, they get to see that. From the highway, you see what you saw on John's sides, kind of just a mound of dirt. There is one spot on the project, though, as you saw earlier in John's slide, where you do get to see that natural rock texture from the highway, and that is the decorative wall at the scenic overlook. The next item I'd like to talk about is the landslide repair. Now, the majority of that was the grading accomplished by CSI to create that 3-tiered system. Engineer and construction innovators did install the horizontal drains, and then CSI installed the collector pipe system. Now, the top bench of the grading did not have any horizontal drains in it. The middle and bottom bench were both intended to have 7 arrays with 5 110-foot long drains per array. However, in the field, we did modify that a little bit due to site geometry and also just trying to get the drains where they were actually collecting water. So a few of the drains ended up with a few of the arrays ended up with 6 drains per array, and a couple of them ended up with only 4 drains per array, but we maintained the planned quantity for total drains. And just kind of quick and dirty of how these were installed, the contractor would come in and drill that 110 feet into the landmass. They would then remove all their tooling, insert that slotted PVC pipe for the majority of it, except for about the last 10 feet where it would switch to a solid PVC pipe, and then there was a grout seal with that sacrificial casing. You can barely see on that left-hand side photo there, that metal. And then that grout seal would force the water that was in that slotted PVC to enter that solid PVC where it connected to this flexible HDP pipe that went to the collector drain system. The handoff between engineering ECI's work and CSI's work happened at that that flexible pipe. Now, the collector drain system was basically a really thick geomembrane on the ground, your typical drain tile flexible slotted pipe, covered in P-rock, wrapped in separation fabric, and then one unique thing about this installation is then topsoil and seed was placed on top of it. And the collector pipe would just bring the water along the base of basically the bench over to the side where it would come down through a pipe buried in the ground and enter into the ditch through a head wall. The next item I'd like to kind of discuss were the jack and bore pipes. Horizontal boring and tunneling performed all these. There were 15 total bores, varying in lengths from 60 to 374 feet, and in diameters from 24 to 42 inch. There were some access issues with either the existing terrain or the construction sequencing. As we mentioned, this was a 2-year construction project. CSI, however, wanted to get horizontal in here and only have them mob in once in year 1. Due to this, there were some spots towards the north end of the project where grading wasn't required to happen year 1, where when horizontal got there to set up their bore pit, their bore machine would just be hanging out in the air because the material hadn't been moved there. This was pretty easily overcome by CSI just moving around their dirt crews to get up and build these bore pads. You can see that on kind of the left-hand side photo there. That middle photo is more of your typical bore pit. And as I'm sure everybody's aware, when you do a jack and bore pipe, your bore pit needs to be at the same grade as the pipe you're actually going to be installing. And lower right-hand side is bore 2. I want to talk about this one specifically. This one had some existing terrain issues with the access. The contractor, due to the existing right-of-way, had already selected shorter lengths of pipe segments. This bore was supposed to be installed at just under 24% grade. This was going to create the back of the bore pit being about 16 feet below grade, which doesn't seem like a big problem. You look at that middle picture, we're well over 16 feet deep. However, that 16-foot cut was right at the base of about a 100-foot tall, 1-to-1 hillside that had moved and slid a little bit during construction. With that, the contractor had some safety concerns. They couldn't find shoring designed to withstand that amount, that weight of material. And also, if that hillside were to start coming down, even if they had shoring, it would just fill it up. The contractor proposed at zero cost to the department, moving the start of the bore 15 feet east and 10 feet up in elevation. This would result in a slightly shallower grade of pipe, but main goal here was to get the back of that bore pit raised up to be at ground level. And then from that 15 feet, they moved it. They were going to install a bend, continue that smooth wall steel pipe to get back down to the planned invert elevation to enter the manhole, and then a second bend at the manhole to have the pipe enter the manhole perpendicular to the manhole. Initially, there were some concerns about the velocity increase that increasing the steepness of that end of the pipe would create. However, it terminated into a drop manhole, so those concerns were alleviated and that change was approved, and we were able to move ahead safely and at no increased cost to the department. Last item I want to talk about real quickly is the paving. That was a pretty major effort. As I mentioned, 49 days of paving. This was accomplished through 4 separate plant sites. We did have a plan note requiring a hot seam everywhere except for centerline. This typically resulted in 2 pavers paving and echelon paving, as you can see in the left-hand picture there. However, at certain areas like the scenic overlook, we ended up 3 pavers wide echelon paving. And for the FAA 45, we came in at just around 190,000 tons, which was 1.5% under plan quantity. And the FAA 42, which was only used on the trail, was right around 15,000 tons, 1.2% under plan quantity. So pretty good yields, especially when you consider the 4 separate plant sites over 2 years, making it kind of difficult to keep track of that stuff sometimes. And with that, I'd like to take a moment to thank everybody who worked on this project through its 10-year life cycle from initial to construction. And I think we're about out of time, but open it up to any questions. Doesn't look like we have any questions. Thank you, everybody.